All right, just quickly walking through the do now, we have our probabilities here. We're told that there are 50 trials, so we're able to quickly calculate those in terms of fractions, and then the decimals, and then if we wanted to, obviously moving the decimal 2 times for the percent. So when we look at how many more draws, so this is 50 green cubes. This is a specific event that we are looking for, so that's our quantity. We're trying to figure out how many whole draws we would need. So 50 is equal to 0.16 times W. Solve it and we get approximately 312.15 or 313. It says how many red cubes, so that's our specific outcome. That should go in for our quantity, but we don't know what that is. We are told that we're drawing from the bag a whole 225 times. So we're plugging in the probability for red cubes, since red cubes is what we're talking about. 0.36 times 225 gives me 81. So really today we're preparing for the test, so KIPSers will be able to prepare for test. This is really in a lot of ways very similar to the test. So what you're going to be doing is working with your partners to go through this and then check your answers. So make sure that you finish each problem before you move forward. All right, so looking at this first one, it says estimate the probability of randomly selecting a student that has 2 pets. So with 2 pets, we can see that's exactly 15. We're told that there are 50 students, so we don't really have to bother adding this up. 15 out of the 50. That gives me a 0.30 or 30% probability of randomly selecting one of those students. Estimating probability has 2 or less pets. 2 or less, so that includes everything that I've circled here. And so when I add that together, that's 43 out of the 50, so that's a 0.86 or 86% probability of randomly selecting somebody who meets that criteria. So we're given the probability distribution here. There are 2 things wrong with it. One is we identify here that there is a negative probability. Something cannot have negative probability. It can be impossible, which would be 0 probability, but can never reach to negative probability. The other thing we notice is that even if I look at just the first 4 pieces here, I can see that I'm well over 1 whole, and we can't have our probabilities in a single event add up to more than 100%. All right, make sure that you've, again, gone ahead and you're working ahead. I'm pausing a little bit in between each video or each question, just in case you haven't had time. Please go ahead and be pausing in between. All right, the spinner below is divided into 8 equal parts. So in this game, what is the probability to score 2 points? That means we're landing on the 2-point wedge. That's 1 out of the 8 possibilities, 0.125, 12.5%. The next one says if you're equally likely to land in any wedge, the probability that will score 2 or 3 points. So we're either scoring 2 or 3 points, so we have a choice here. We're landing in this upper right-hand corner. That's 2 out of 8 or 0.25, 25%. It says below are the probabilities of the results of 100 spins for 1 player. Does this appear to have a tendency to land in the upper right more often than we would expect? So just a hint on this one, if you're starting this one and you're not sure where to start, we just calculated the theoretical probability, what we would expect for the upper right-hand corner, because the upper right-hand corner is the 2 and the 3. So we would expect it to be 25%. So what you might want to do is you might want to go down and determine the observed probability of landing in the 2 or 3. If those are not the same, then or close, then we might be considering that they are not equally likely. So looking down here, the theoretical probability I've just written over here was 0.25. That was what we calculated up here. The observed probability, we add the 2 together, we get 41 out of the 100 is 0.41. That's what we observed. 0.25 is significantly less than 0.41, so the observed shows a higher tendency than we would expect. And as a result, we wouldn't necessarily think that they are equally likely. All events don't appear to be equally likely. All right, so 14 of its 100 customers, so that means there's probably 14 out of 100 will purchase, or 14%. It says the company estimates the probability that a randomly selected male customer will purchase 0.20, so the probability there is about 20%. And it's asking if that implies a randomly selected female customer will purchase is 0.80. So when we look at this and we think about it, we've really got to dive deep into what our possibilities here are. Our possibilities are not just that somebody purchases, because when we look at our tree diagram here, we either have people purchasing or not purchasing, males or females. So we have all of our outcomes over here would have to add up to one whole. And so it doesn't make a lot of sense that all of our outcomes would be here, and that would mean that there's a 0% chance that people are not going to purchase. And so that wouldn't make a whole lot of sense. So no, there are 4 possible outcomes here, so all 4 need to sum to 100%, not just 2 of them. What we would say is that the probabilities of a female purchasing and a female not purchasing, those would be questionable as well. So according to the data, which of the following is more likely? So a male customer purchasing a candy bar, they just told us in the previous problem that was 0.20. And any customer purchasing candy bar, that's what we actually started off here, this was just 14 out of 100, so 0.414 or 14%. So we can see that this is a greater probability that a male customer will purchase a candy bar as compared to a female customer. Another thing to think, or any other customer, another thing to think about though, is that also means that it's going to be greater than a female customer, because female customers would have to bring that percentage down when they were added to male customers. All right, so suppose a candy bar salesman sells 4 different types of candy bars. We're going to randomly select a candy bar at random. So what are the outcomes in this sample space? Well, if we're selecting a random candy bar, that means our outcomes in our sample space are exactly the list of candy bars. So here I have the 4 different possible outcomes. Salesman wants to assign probabilities to the sales of the 4 different types of candy bars. What's wrong with each of the following probability assignments? So as we're looking at this, if we sum all of these probabilities, we're going to get 1.1, which means that the probabilities would sum to greater than 100%, and so that's not possible. With the second one, we see this negative probability, and you can't have a negative probability. All right, so now consider the chance experiment where we are randomly selecting a customer, and we're also going to be figuring out whether or not they purchased more than one candy bar or not. So when we look at this, there are possible outcomes here. We can get a caramel bar and more than one. We can get a caramel bar less than one. And so I'm going to use a tree diagram here. You can kind of see in the space that I gave you, there wasn't a lot of space, but caramel greater than 1, caramel less than 1, chocolate greater than 1, chocolate less than 1, probably peanut butter greater than 1, less than 1, chocolate or coconut greater than 1, less than 1. So here's my list over here of all the possible outcomes. So I see that there are 8 total possible outcomes here. It says equally likely, so the customer bought exactly 1, so that's going to be if they purchased and it's less than 1. And so when we see that, we're looking at our coconut is going to be equal to 1. So that's 1 out of the 8 outcomes, or 0.125 or 12.5%. And finally, we get down to this question. It says, suppose a salesman randomly selects 500 of its customers and finds 140 of them purchased chocolate bars and purchased more than 1. So this is going to be 1 out of 8. So this is 1 out of 8 of the things that we would expect. So we would know that our expected would be 12.5%. So there's a couple ways to go about this. One way I have over here on the left-hand side. Basically, I found out what the actual percentage was. We expected it to be 12.5, but I find that it's 28%. So the actual percentage is significantly higher than the expected. So that would suggest to me that that was not as equally likely as we expected. The other way to go about this would be to, okay, well, if it's 0.125, how many candy bars would we expect them to, or how many of these particular candy bars would we expect them to sell? So 0.125 of the 500 would give me 63, which is significantly less than what we expected, or than what we actually got. So the expected outcome was way less than what we actually got. So again, that would suggest that they are not equally likely. So yes, you should absolutely question this. And depending on which method you chose would depend on how you decided to answer that question in terms of the explanation. All right, go ahead and flip on over to your alone time and then get your work done on Khan.